Okay, so I just showed you basically what's going on with the circuit here, and I'm just going to have a go at answering those questions I set on page in the PowerPoint that I sent you. So, or no, it was on Caboodle actually, wasn't it? So it says a battery of EMF 12 volts. So I'll put the little internal resistor there. Is connected to a 4.5 ohm resistor. It says it's got an internal resistance of 1.5 ohms. And that's it. Right, okay. So that I know I'll do a little circle around there because that's all going on in the battery. And the first one, calculate the total resistance in the circuit. Because they're in series, you just add them together. So 4.5 plus 1.5. That gives you 6 ohms. B. The current through the battery, just use V equals IR. So I is the total voltage available over the resistance. So that's going to be, hang on, what was the EMF? 12 volts, wasn't it? So that's just going to be 12 over 6, which is 2 volts. C, the lost PD. Now the lost PD means this bit, the bit over there. Okay, that little bit. So that's just the lost PD is a little v. So that's just going to be I little r, which is, oh, we haven't done the current yet, have we? Oh, sorry, that was the current, 2 amps. So that's 2 amps because the same current is going to be going all the way around times 1.5, which is 3 volts. So that's what we call the lost volts. And so the PD across the cell terminal will be 12 minus 3. Which is 9 volts, because that's how much is left once that little 3 volts has been used up inside the battery. Okay, question 2. Question 2, it was a cell of 1.5 volts. So we got a 1.5 volt cell, and then we had an internal resistance of 0.5 ohms connected to a 2.5 ohm resistor. Like so, and it asks you for the current. So for the current, you have to first of all work out what the total resistance is again. So that's 2.5. Can you see that? 2.5 plus 0.5. So that's 3 ohms. And then we know that the total voltage in that circuit is 1.5. So we can work out the current using V over R, which is 1.5 over 3. Which is 0.5 amps. Okay, then B, the terminal PD, that's basically the big V. That's the voltage across the whole battery. So you could put your voltage there, or you could put your voltage there. That's the big V. So that's I times big R, which is going to be 0.5 times 2.5. And then C is the power delivered by the 2.5 ohm resistor. So for power, you can use either I squared R, IV, or V squared over R, whichever is most useful. And we want to find it on the 2.5 ohm resistor. We know the current, so I'm going to use power is, oh, can you see that? Sorry. Power is I squared R, which is going to be, where's the current again? 0.5 squared times 2.5. And then finally, the power wasted in the cell, that is going to be the little resistor, the internal resistor, so that's I squared R. And you work that out as 0.5 squared times 0.5. And I'll let you work those out. Okay, so that's how you do question 1 and 2. I'll pause that for a minute and then show you how to do question 3 and 4.